Welcome back. In the last video, we explored operators and learned how to perform actions and evaluate conditions in Java. Now we are going to learn how to make our programs more intelligent by enabling them to make decisions. This is where control flow statements come in. In this video, we will focus on two fundamental control flow structures, the if-else statement and the switch statement. These statements allow our program to execute different blocks of code based on whether certain conditions are true or false. My name is Oleg, it's Dev Nights, let's get started.
Okay, let's go back to our IDE and see in practice how to work with conditional statements. I'll hide the left part, we don't need it right now anyway, so we'll have more space for code. Conditional statements in Java let you make it so that specific code will only execute when certain conditions match. Let's imagine some popular use cases for this. For example, if a user meets certain criteria, then, let's say, we'll allow them to use our application. Let's write that down. Allow to use app. Otherwise, if they don't meet certain criteria, then we'll forbid them from using the application. So I think the logic is clear. Popular scenarios where we have two or more possible outcomes. In Java, this is implemented using two conditional statements. The first is if-else, and the second is switch. We'll look at each of them separately. Let's start with the first one, if-else. Let's imagine we have some number, called number, with a value, for example, -5. And we want to write a program that will check if the number is negative, it will tell us about that. And if the number is positive, it will again tell us about that in the console. In this case, we'll use if-else. The syntax for it is as follows. If, then parentheses, and in them we need to write a condition that will be true or not true. For example, in our case, we need to check the number variable to see if it's greater than 0 or less than 0. So we'll write if our number is less than 0, and then we need to make a new code block, which in fact will execute if this condition matches. A code block opens with curly braces and closes with a closing curly brace. So everything written between these curly braces will execute only if the condition inside the parentheses after the word if is true. In our case, let's write some message, something like number is negative. Let's run the program and see if anything prints to the console. Yeah, we can see that the message, the number is negative, was output to the console. So our program is working correctly. Let's go over the syntax again. The keyword if indicates that we're starting our branching now. Then, in parentheses, we write the actual condition, which as a result of its evaluation. I mean, if the condition itself is true, then the code block, which is located between the curly braces immediately after the condition, will be executed. If our number is positive, let's say just 5, then this block of code will never execute. You see, no message was printed, so this block of code didn't run. So we didn't enter our statement. If we want to do something if the condition doesn't match, then in that case we have an additional keyword, which is called else. We write it immediately after the closing curly brace of the if block. You can write it on a new line, but I'm used to writing it on the same line, and then we open new curly braces, that is a new block of code. Here it opens, here it closes, and everything inside this code block will happen only if the initial condition doesn't match, that is not equal to true. And everything that is inside this block of code will execute only if our initial condition doesn't work, that is, when number less than 0 here isn't equal to true. As we remember from the previous lesson, all expressions that use comparison operators, they return either true or false in the end. The if block will execute only if inside the parentheses, after evaluating this expression, we get true. And if it's not true, then the else block will execute. So, let's write something else here. Since in the first case we were checking for less than 0, let's write here that our number is positive. And in this case, when we run the application again, we see that our first if block didn't run, the code executed line by line, and it reached this line, checked if the number was less than 0, it didn't match. It checked that this condition isn't equal to true, which is to say that it's not actually less than 0. So it skipped this block of code and immediately jumped to the else branch, and executed it, as we see in the console. If we change number again, then in that case our first block, number is negative, will execute, and the else block won't execute. So again, an if-else block means that the code will execute from either the first branch or from the second branch. There are no situations where both the if block and the else block will execute at the same time. It's either one or the other. The else block is not mandatory. you can omit it, and we'll just have code execution if our first condition matches. Then all subsequent code will execute as usual. Let's bring back else. If you're fairly observant, you might have noticed that this code actually isn't working correctly. And it's only working incorrectly in one case, when our number variable is equal to 0. 0 is neither a positive nor a negative number, so let's check what happens in this case. Number is positive was printed on the console, which is not true because 0 is not a positive number, so we need to somehow fix this error. The current branching doesn't let us do this. The only thing we're checking is whether the number is less than 0, and in all other cases we output the second message. But in our case, we don't have a case that checks if the number is 0. So in these cases, when we have several conditions, then we get an additional branch. It's called else if. I'll put this else a bit lower down so it doesn't get in the way. And also after the closing curly brace of the if block, we can write else if and then open new parentheses, where we'll put an additional condition. After this condition, we will again have another code block, which will execute when the condition in these parentheses matches, in the parentheses after else if, but the condition of our first if doesn't match. So let's write an additional condition here. If the number is greater than 0, then we see the message that we output earlier, number is positive. I'll cut that. And then after else if, we can again put our else block, like we put it after the if block. And then we'll have all other cases. This is the only case when the number is 0, like it is right now. So let's write number is 0 here. And now this code will work correctly with any number. Let's run it with 0 and check. It says number is 0. Let's change the number to -3. It says that the number is negative. Let's change to +3. It says that the number is positive. Everything's great. Now our program works correctly, thanks to the fact that we added an additional condition. Let's go through this whole block again to understand the logic of code execution here. First, when the code reaches the execution of line number 11, we evaluate the expression that's inside the parentheses. This expression will return either true or false. That is, number less than in this case will return false. So if the value returns false, then the next code block after the keyword if doesn't execute. If the expression inside the parentheses returns true, for example, when the value is -3, then in that case the code block is executed and all other code blocks are not executed. But let's go back to the case when this condition also doesn't execute. The code reaches the execution of this line, checks our number is less than 0, it returns false. So we skip this code block and go to the next line. The next line we have is else if. This is an additional check. It will only execute if the previous if returned false. The next check checks if the number is greater than 0. In this case, our number is actually greater than 0, so the expression inside the parentheses returned true, which means this code block, just like a regular if, will execute. In the case that this code block also didn't execute, then in all other cases, regardless of any additional conditions, the else block will execute. It executes only when none of the conditions above in this chain have returned true. In our example, there can only exist 3 conditions: when the number is less than 0, when the number is greater than 0, or when the number is equal to 0. But there are conditions where there can be many more possible outcomes, and in such a case there can be more of these additional else if blocks. There doesn't have to be only one. In one such chain, there can be 0 or 1 else blocks, 1 if block, and as many else if blocks as you want. That is, if we need to check something else, let's have this else. We can have another else if that checks something. Then we can have another one that checks something else. And only after that we can have an else block. It's clear that in such a case we don't have any logic in this. I've just filled in true-false values to avoid compilation errors. But in general, this code can be in one chain. It's important to understand here that this is all one chain in which we are working with our number variable. That is, we are twisting all our conditions around it. And in this whole chain, only one code block can execute. Either this, or this, or this, or this, or the very last one, in the case that none of the code blocks were executed. Let's remove these extra else ifs. Let's put everything back the way it was before. And why did I mention that this is all one chain? Because if we write a new condition after this chain, for example, if we check again, if number is less than 0, Then, for example, we'll do something else. Then in this case, this will be a completely new condition that doesn't depend on the previous one at all. So in this chain, one of the conditions executes, but further, since this is a new if, this is a completely new condition. We don't relate to the previous results of the previous if in any way. This is a completely new if, a completely new code block. Accordingly, here we can work with our variables again, with our data, and check them again. For example, in this case, let's make the value negative, and we'll see that both the first if and the second if, which we wrote here separately, executed. That is, this is a completely different logic block that has nothing to do with this chain. Let's move on. I think that's clear. And let's return a bit to our expressions that we wrote in the previous lesson. Let's remember we had expressions like this. We wrote that some Boolean value is allowed was equal to something. Let's prepare some data for this. I'll create some additional variables here now. For example, let's create a Boolean variable hasid equals true, and some balance of type double with some value. Let's say we're already talking about users, about whom we know something, and based on our knowledge about the user, we have to make some conclusions in our application. And let's remember, we had expressions like this that we wrote something like we allow the user access if, for example, our balance is greater than or equal to 50, and let's add some additional conditions, and they also have an ID that is hased equals true. Yeah, you remember we wrote something like that? Let's move this a bit lower down so that the previous example doesn't distract us and will work here. So, having any value of type Boolean, we can use it right in our conditional statements. Remember, I said that here, the value number less than 0 will return either true or false. So, having a ready-made value of true or false, we can substitute it in our if statement in the same way. For example, we can write if isAllowed equals true. Yeah, that is, we have a double equals. We're comparing that if our isAllowed value is true, then we do something. Let's write something like access is granted, which will mean that the user has been granted access to the application. And in all other cases, that is, when isAllowed is not equal to true, we'll write something like no access. Something like that. And now, having run this program, let's see. Yeah, we see that access is granted was printed. That is, initially the value of our variable isAllowed was evaluated in this line. First, check the balance. It's actually greater than 150. Yes, that's true. The hasid value is true. That's also true. Accordingly, the value of isAllowed will be true. And here we're just checking if it is true. It is indeed true. And accordingly, we're printing to the console access is granted. If, for example, hasID is false, then in this case, we'll see no access. That is, you have to understand here that in the parentheses of the if operator, we specify any expression or value that has a Boolean type. But there can be some complex condition here, for example, like it was here, which in the end will return true or false. We can have a ready value of true or false here. The most important thing that if statement is interested about specifically is that in the end, inside the parentheses, it should have either true or false. If it's true, then the code block will execute. If it isn't true, then the code block won't execute. This code can also be shortened a bit. I didn't mention this in the previous lesson, so let me tell you now. In the case of this code on line 23, when we're calculating the value of the variable isAllowed, we see that in the second part of the expression, we have a record like this. Hasid equals true, which means that true will be the result if the value of the hasid variable is equal to true. But this is actually a slightly redundant syntax because in the end, the value of this sub-expression will be true only if the value of the hasid variable itself is true. This means that we can omit this comparison altogether and just write hasid. Because basically, as I'm saying, it doesn't matter what you write here, an expression, a comparison, or a ready value. What's important is that in the end it should be converted to either true or false. And our hasid variable, it is already either true or false. So we can omit this extra calculation, which basically just doesn't make any sense here. Hasid will be true, so the result of the sub-expression will be true. If hasid is false, then the result of the sub-expression will also be false. It's equivalent to what is stored in the hasid variable itself. Exactly the same inside the if. Here we also write if isAllowed equals true, then we do something. Again, the value of our isAllowed corresponds to what will be calculated inside this expression. This expression The isAllowed equals true expression itself will only be equal to true if the isAllowed variable itself will be true again, and the expression itself will be equal to false if the initial variable is equal to false. Therefore, here too you can omit this record and just write, if allowed, do this, otherwise, do that. That's it. It seems to me that it's a bit easier to read in this form. Let's run it. Check that everything works like before. Yeah, no access, because our HASID is false. Overall, I think I've covered everything I wanted to about the if-else statement, right? But we remember that we have one more, switch. So let's move on to that. Let's have a value of type int, say day, which will be equal to some number in order for the day of the week. For example, 1 is Monday, 2 is Tuesday, 3 is Wednesday, and so on. Then, based on what number we've written in this variable, we have to output the name of the day of the week to the user on the console. For this, as we learned above, we can use an if statement. Yeah, we can write something like if it equals 1, then we'll print, for example, this is Monday. Then, in the next case, if our first condition doesn't match, we can check this variable again, if it equals 2, and so on. I think you understand. But it's more convenient to use a different conditional operator called switch for these cases. It looks roughly like this. We write the keyword switch, then in parentheses, we specify the variable that we're going to check against something. In our case, it's the day variable, and then the body of our switch statement opens. That is, we open curly braces, and everything between them will be the body of our switch statement. Then we must specify all the cases, all the possible variants of the day variable that interest us. In our case, we're interested in the values 1, 2, 3, 4, 5, 6, and 7. That is the 7 days of the week. In these cases, we will do something. In all other cases, we will do nothing. That is, inside these curly braces, we must specify the first case. In order, it is specified with the keyword case, and then just with a space, the value with which we're going to compare our initial day variable is specified. Let's say 1. Then a colon is put, and on a new line, the action is written. What do we actually do if the value of the day variable matches 1? We write, for example, that we want to print a message "This is Monday" to the user on the console. Then, in order to finish the execution of this case, we have to write the keyword break. Lots of new keywords, we'll look at them now, and then we'll go through them again, so that we finally solidify everything in our heads. Then, in the second case, when the value of the variable is not 1, but, for example, 2, we have to specify the next case. We write case 2, and again, I'll just copy it. The next action that we need to execute if our day variable value is equal to 2. We write this is Tuesday and so on. Let me just quickly duplicate everything and then we'll go through how it all works. Okay, I finished writing our switch statement. It turned out to be quite big. Let's understand what's happening here. The keyword switch indicates that we're going to do a selection. In our case, we're going through the possible variants of our day variable. In the case that it is equal to 1, the following code block will execute. System out print line, this is Monday. If this code block doesn't execute, then the value of the day variable will be checked against the next value, the value 2. If the value of the day variable is equal to 2, then this is Tuesday will be output, and so on. Let's run it, check what's output to the console. We are expecting Wednesday. Yeah, we see that Wednesday was printed. So just like in the case with if, one of the possible variants is executed. It's important to note here that it's mandatory to use the keyword break. Otherwise, our program will start to work incorrectly. These are the syntax requirements. Let's comment out all the break calls right now in order to see what will happen in this case. Let's run it again. And we see that, starting from Wednesday, all the other code blocks were executed, regardless of what value was in the day variable. These are the features of how switch case works in Java. That is, until we get to the necessary value, everything will work correctly. In the case of the value 3, the code blocks for cases 1 and 2 will not be executed. As soon as the code execution reaches the correct code block, in our case it's 3, it and all subsequent code blocks will be executed regardless of the value. That's exactly why we need to add the keyword break, let me return it, which will stop the execution of the entire switch, our entire statement, all the way up to the moment when we close the curly brace of the switch. I agree, it doesn't look very convenient, there's a lot of repeating code, but that's how it works in Java. Then, after the last case, at the very end, we can write the keyword default with a colon. like in the case of case, but without any value, just default. And on the next line, we can write any value that will be output to the console if none of the above conditions are met. Let's write something like invalid day. And now, let's try to change the day variable to 0, let's say. Let's run it and see that the output is invalid day. None of the conditions worked, therefore the very last condition, default, worked. It won't work if at least one of the above conditions works. After default, you don't need to put the keyword break, because it's always the last one anyway. After it, nothing will be executed within the scope of this switch statement. Let's slightly change the conditions of our program in the case of these days, and let's look at another variation of writing switch. Let's say now we want to not check what day of the week it is specifically, but we want to know if today is a weekday or a weekend. For this, let's go back to Wednesday again. We can remove all of the non-interesting code blocks, the case blocks, leave them one after the other. For example, in the case of the first case, or in the case of the second case. Or in the case of the third, fourth, and fifth case, we'll write this is a weekday. And in the case of the sixth and seventh, we'll write this is a weekend. And in default, we'll write invalid day. Let's leave that as is. That is, by removing the code blocks and accordingly removing the keyword break from each of the cases, we're saying that we will execute this block if any of the higher up cases are executed. In cases 1, 2, 3, 4, 5, we will execute this block. In cases 6 and 7, we will execute this code block. If none of the above conditions works, then we'll execute default. Let's run it. Make sure everything works okay. This is a weekday. Correct. Let's change it. This will be a weekend. This is a weekend. Everything's working perfectly. Great. Let's move on. Switch case can be used not only to execute some code when a value matches our variable. We can also use switch case to assign some value to a variable. The syntax will be a little different. Let me show you what I mean. In our case, let's say that we want to create a new variable in which a value will be placed, for example, this is a weekday, a string, if our day variable was equal to between 1 and 5. And we'll put the value, this is a weekend, in the new variable if our day variable's value was 6 or 7. And we'll put the value invalid day into the same variable if the value was outside of those ranges. To put a value into some variable, you need to actually declare it. And we haven't discussed the type of this variable yet. We'll do it in the following videos, but in general it's called string. Let's write it. It's written with a capital letter, unlike other types. Again, we'll discuss this in future videos, don't worry about it for now. The point is that if you want to store some string in a variable, you need to create this variable using the word string with a capital letter. Let's give this variable a name. Let's call it type. And we'll put a value into it based on our switch case. This is how it looks. After the equals, we write the keyword switch. Again, in parentheses, we specify what we're going through. We're still going through the day variable. And just like before, our switch statement's body will be in curly braces. Then the differences begin. Since here we're using the switch statement already as an expression, that is, we want to use the result of the switch expression in order to put it into some variable, then the syntax will be a little different. We write case again, and then, separated by commas, we list all our possible values for the first case. The first case is our workday, so let's list them with commas. If this were one case, then we would just have one case without a comma. In our case, it's 1, 2, 3, 4, and 5. And then we put a dash and a greater than sign. That is, we draw an imaginary arrow. It's a minus sign and a greater than sign. And at the end, in double quotes, since strings are specified in double quotes, we write the value of this variable. This is a weekday. And we definitely put a semicolon. What's happening here? Let me repeat. We're saying that we want to create a variable named dayType, inside which we'll put a value based on the execution of our switch statement. Just like here, we're checking some value inside switch. And based on the value of this switch, we're specifying a value for our new variable. That is, if our variable day stores the value 1, 2, 3, 4, or 5, then we'll write this is a weekday into the dayType variable. We have the next case, when the value of the day variable can be 6 or 7. In this case, we'll write this is a weekend into the variable. And in a switch of this type, our default branch is mandatory. Since here we're assigning some value to our new variable, we have to cover all possible outcomes. Our day variable in theory can be any number, but we only listed the variance from 1 to 7. So in all other cases, we still have to write something in this variable. Therefore, the default branch is mandatory here. Again, we put the same kind of arrow and we write what the variable will be equal to in all other cases. It will be equal to invalid day. We write it and definitely put a semicolon. Then, unlike all other code blocks, it's very important to put a semicolon at the end of this curly brace. In principle, the IDE will prompt you or the compiler will prompt you if you run it. For example, if we run it like this, we'll see that we're expecting a semicolon on a certain line. The line is written here, right? 54. A semicolon is expected on line 54. That will indicate that we missed it here. It's mandatory here. Again, why is it mandatory here? Because in the first case, we used switch case as normal branching. We were executing some code based on our condition, and here our switch is an expression in itself. That is, we're calculating something inside this switch, and accordingly, since it's an expression, at the end of each expression, we are required to put a semicolon, just like in the case of this line. Here we calculated some value based on some conditions. This is an expression, so we put a semicolon. Here we've called some functionality. Calling any function is also an expression, so we put a semicolon. It's the same thing with the switch when we are calculating something inside it. And then, accordingly, we can use the value of this variable in any scenarios we need. Let's, for example, just print it. Daytype, and let's see what's happening here. Daytype, we get this is a weekend. We see the very last thing that was printed is this is a weekend. The previous time it was printed from this switch case. Let's comment it out so that it doesn't get in our way. And let's try to run it again. We see this is a weekend because the value of the variable day is 6. If it was equal to, for example, 1, we'd get weekday. I think that's all clear. But what if in this type of switch expression, we need not only to assign a value to some variable, but also execute some code? For example, to print something additional here, if it's actually this case that's triggered. In this case, after our arrow, we can put additional curly braces, inside which we'll write both the code that needs to execute and set the value of the variable, as we should in this type of switch expression. So let's put curly braces. Now the IDE will probably put the additional braces for us automatically. Yeah, that is, we opened the brace and the IDE closed it for us. And let's say, for example, that here we want to print something additional. For example, we'll print something like a normal informational message. For example, in the range, like that. But then we need to somehow actually pass our value to our daytype variable. You can't write it just like that here. Unlike this record, when we can just specify a value after the arrow and it will be passed to our daytype variable. Here, when we've put additional curly braces to execute some additional code, there can be multiple messages, right? That is, we can have as much code as we want here. But at the very end, we must say that we still want to put something into our daytype variable. And in order to say that, you need to specify an additional word. Yield, this is a weekday. This word will only be used here if after our case, after the arrow, there's some additional code block. That is, we're doing something additional, and then we must return the value that will be written to our variable. Let's run it and see that all this bunch of messages is now output. We are in the first branch 4 times, and then our actual variable's value, which we're printing in this line. So each of these case branches can contain some additional code block, but in that case, if we're already writing a code block, then before the returning value, this is a weekend, we must put the keyword yield. But when we don't need to execute any code, we just want to specify what the value will be in the final variable, then there's no point in specifying the curly braces, and the word yield is not needed either. We just specify the value that will go to our daytype variable after the arrow. So, how do we understand when to use a switch and when to use if-else? Use if-else in those cases where you have a range of values. For example, when you're using operators like less than, greater than, you don't have a specific value, you just know the range from negative infinity to 0. Or use if-else in cases where you have a combination of several conditions. For example, as in this case, when we are comparing both the value of a variable and the value of a second variable. In general, in any complex conditions, when multiple variables are involved, multiple additional conditions and so on, it's better to use if-else. But when you have a certain value, and you need to check if it falls within a specific set of possible actions. For example, when we have only 7 specific cases within which we must do something, then in such cases you need to use switch. In short, if you just need to go through all possible variants of a variable's value, use switch. In all other cases, use if else. That's all for this lesson. We've discussed both ways to create conditions in Java. If something was unclear or confusing, try watching it again from the beginning, and I hope that it becomes clear.
Excellent work! You've now learned how to control the flow of your Java programs using if-else and switch statements. These are essential tools for creating programs that can make decisions and respond to different situations. In the next video, we'll dive into loops, which allow us to repeat blocks of code multiple times. Remember, you don't learn programming when you are not coding, so practice writing different if-else and switch statements. Experiment with different conditions and values. If you have any questions, please leave a comment below. Don't forget to like this video and subscribe for more Java programming tutorials. See you in the next one, and happy coding!